In this video, we're going to talk about the cabling used in today's networks, as well as how to identify the appropriate cable to connect to network devices. Ethernet is the most common network technology today. It's used for both LAN, local area network connections, and WAN, wide area network connections. Ethernet has become the comprehensive network port, or network card type, because it can run over different types of cabling. Let's look at a few examples. You may need higher bandwidth or a connection between larger distances, such as in a data center, where requirements for 10 gigabit connectivity or higher are common. You could potentially need connectivity between different buildings on a campus, or even between a core switch and the access switching on different floors of a building. In these situations, fiber optic cabling is the best option. Fiber optic cabling uses light to carry data. Depending on whether it's multi-mode or single mode, it could span distances of many hundred meters all the way up to 50 miles or more. Fiber optic cabling can also handle much higher data rates than copper-based UTP, which stands for unshielded twisted pair cable. Let's look at what some of the connectors for these types of cabling look like. Fiber optic connections use a pair of fibers. You can see the dual connectors here. These connectors are called SC, or standard connectors. The type of connector is determined by the type of optic that's installed in the network device. If you had a Lucent connector, or LC-based, optic in one of your switches, you would need LC-type fiber optic connectors for the fiber pair. The most popular cabling is UTP, which is copper-based. This type is appropriate for cable spans of up to 100 meters. All workstation connections running at 100 megabits or even a gigabit per second use UTP to connect to the local switch. A much more familiar connector is the RJ45 connector, which is used with UTP. That's what's plugged into an Ethernet workstation port. You can see that there are 8 pins on the connector. We'll discuss the functions of those pins later, but they're basically used for short runs. The bulk of cabling in a network environment is UTP with an RJ45 connector like this. If you split open a UTP cable, you'll see that there are twists of different color-coded cables. Today's 100 megabit per second and 1 gigabit per second Ethernet solutions use 2 of these pairs, 4 wires, as opposed to all 8. It's important to understand how these different wires or pins are terminated within the RJ45 jack. There are 2 types of UTP cables you need to be familiar with. The first is straight through, and the second is crossover. Ethernet uses 2 of the 4 pairs within the RJ45 jack. Those wires are 1, 2, 3, and 6. If you look at an RJ45 connector with the tab facing away from you, the pins are numbered from left to right. Pins 4, 5, 7, and 8 are unused. A straight-through cable means that from end to end, pin 1 connects to pin 1, pin 2 to pin 2, 3 to 3, and 6 to 6. In a straight-through cable, you transmit on pins 1 and 2, and that signal is received on the corresponding opposite side. A crossover cable crosses pin 1 over to pin 3 on the other side, pin 2 over to pin 6, pin 3 to pin 1, and pin 6 to pin 2. Why? Because on a crossover cable, you transmit on pins 1 and 2, but the signaling is received on pins 3 and 6 on the other end. To know which type of cabling to use, just remember that if you're connecting devices that transmit on different pairs, you need a straight-through cable. If you're connecting devices that transmit on the same pair, you need a crossover cable. For example, let's say that 2 workstations are connected to a switch. The data sent by one host over the transmit pair must be received by the destination host on its received pair. If you're directly connecting these 2 hosts without a switch in between, you'll need a crossover. The fact that you do have a switch in between means that either side can be a straight-through cable. To know if a device transmits on the same pair or on different pairs, you need to know which pin it transmits on. Devices that transmit on pins 1 and 2 include workstations and routers. Devices that transmit on pins 3 and 6 include hubs and switches. Now, let's connect a PC to a switch. The PC transmits on 1 and 2, but the switch transmits on 3 and 6. So this will be a straight-through cable. The same on the other side. Let's look at a larger example. We'll draw a network with a couple of routers, switches, and a hub. Then we'll have workstations connected to each of them, including to one of the routers. It's your job to identify what type of cabling each one of these is going to need. Let's start in the middle. You're connecting 2 routers. Routers transmit on pins 1 and 2, so you're going to have a crossover cable here. In fact, this is something you should memorize. Whenever you're connecting two like devices, use a crossover cable. Now, look at the router and switch on the right. The switch transmits on 3 and 6, but the router transmits on 1 and 2. They're different pairs, so you'll need a straight-through cable. Same thing over here. In the previous example, we learned that workstation connections to switches will also be straight-through cables, so that takes care of all of these. Both the hub and the switch transmit over pins 3 and 6. They're the same pair, so you'll need a crossover. Then, finally, the workstation connecting to the hub is a straight-through connection, since they're on different pairs. Identifying a network with many different types of devices and then what type of Ethernet cable you need to connect them are both very important skills that you'll use often. And that's all for now. In this video, we talked about fiber optic and UTP cables, their connectors, and how UTP cables transmit signals.